Good afternoon. Good afternoon. Welcome to the fourth lecture of the distinguished lecture series in electrical and computer engineering. It is my pleasure to introduce James Miller, Chairman, President, and CEO of PPL Corporation, one of the nation's largest electricity company. He has more than 35 years of experience in this industry. He received a bachelor's degree in electrical engineering from the University of Delaware in 1977. He then began his career in the former Delaware Power and Light Company. And he's got a very successful career in this industry. He's a member of the board of several energy-related and community organizations, and recently established a scholarship endowment in our department to support an EE undergraduate student. I can't tell you the importance of the industry. You're very well aware of that. Very recently, the National Academy of Engineering put together a list of the most important engineering achievements in the 20th century. The internet took 13th place. Highway infrastructure took 11th place. At the top of the list was electrification, made possible by the electric grid as the most significant engineering achievement of the 20th century. So without further ado, Jim, welcome back.
Thank you. Thank you very much. Thank you. Well, thank you all for coming. I really appreciate such a great turnout here. It's good to be back, obviously, and thank you, Ken, for helping me out thus far today. And I think I'd like to spend some time with you today, hopefully to educate you about a sector of our country's businesses that I suspect you will find thought, well, sleepy and boring and stodgy and old, but it's really not like that today. It's turmoil and transition in all seriousness. And our sector is going through and has gone through in recent years some of the greatest changes that I could have ever imagined trying to supply electric to our growing country. That being said, it is great to be back, and I have a lot of good memories, and most of them spent in the library studying, but I'm sure that rings a bell with you. I came here to the University of Delaware after serving in the nuclear program with the Navy and submarines, and tour in Vietnam, and spent 6 years, and then came back to the UD campus and pursued my degree, and then went on to a number of companies all across the country, and happy to say now I'm at my 8th and last company in my career, and it's been a great ride. I guess when I left the service and left the University of Delaware, I was bound for the nuclear side of the sector, and was on the startup of Salem 2 reactor over in New Jersey as a young engineer. And I think that was quite a culture shock for me, leaving the Navy nuclear business and moving into the civilian nuclear business. And at that time, that was pre-3 Mile Island accident. So it wasn't much more than a year and a half later that the fuel accident at 3 Mile Island occurred, which changed the entire nuclear industry from a safety perspective, and nearly, I would say, nearly, for the most part, ended the growth in nuclear in the United States, other than finishing the plants that were committed to and underway. As the years passed, we now realize, unfortunately, that was a very serious event that really hurt the industry, and I think long-term hurt the country. Energy, as you well know, is just so essential to the prosperity of the country and to our quality of lives. It's much along the sense of air and water, and so such a direct correlation between electricity use and gross domestic product, which is, of course, a key indicator of our health. There's a great correlation between electricity and the ability to provide it to people and literacy rates. And in the undeveloped countries, we now see tremendous growth in the need and the demand for electricity in all of the developing countries. And so there are tremendous opportunities in those areas to help foster the development of electrification. The technologies, they create jobs, educate children, connect the world, and they save lives. And there's no question about that. And many of you are embarking in areas in the electrical engineering area and computer engineering that just as well will serve the country and the world in those areas well. There's an insatiable appetite for electricity in this country and, of course, worldwide. It's grown unabated, except for this temporary, and I certainly hope temporary, downward blip caused by the recent downturn in the economy and a financial collapse of the markets. Sales in the United States have grown by about 1 billion megawatt hours, about 37% in just the last 20 years. So a considerable growth rate for a commodity such as electricity. The Consumer Electronics Association, I found interesting, noted that the average household in the United States contains 23 devices powered by electricity. So I guess if I got out here and walked through your dorm areas, we'd find computers and televisions, flat screens, video games, DVD players, and iPods, iPhones, GPS devices, and probably devices that I don't even know exist. DOE, the Department of Energy, in its energy outlook, still predicts that the demand for electricity is going to increase another 28% in the next 25 years. And that, ladies and gentlemen, is going to be an issue. It's going to be a real issue for this country that we're all trying to deal with right now. And I might say, the next 25 years is an issue you're going to deal with, not so much I am. All of which leaves us with one fundamental question. Okay, where is it going to come from? Where is it going to come from? So let's talk about where are we today? What's our situation? What's your situation today in this country? Many of you may know 45% of the electricity generated across the United States in 2009 came from coal. 24% from oil and natural gas. 20% from nuclear. 7% from hydroelectric. And 4% from other forms of renewable energy. And of that 4%, I might add that at the end of 2009, of that 4%, about 1.8 to 1.9% of it is now attributable to wind. So people are always interested in knowing how much is coming from wind. Currently, about 1.9%. One number there I know is particularly striking when you think about it, especially in light of the discussions that are going on in Washington. coal-fired power plants, and 45% supply of the nation's electricity. Concern for air quality, water quality, and climate change is really increasingly driving very stringent conditions and regulations on the use of coal to generate electricity. The company that I'm associated with, we're 50% coal, 30% nuclear, 12%, 13% hydro, and the rest is gas and oil. This controversy of climate change, and are we going to have climate change legislation, are we not? Is it going to be thrust on the economy, or is it not? This has created a world of uncertainty in the realm of power producers to say, I'm not sure I can get a new coal plant permitted. I'm not sure I want to attempt it because I don't know that I can be allowed to start it up after the years of litigation and intervention, and meanwhile the meter's ticking and you're spending literally billions of dollars to get a plant built. Wall Street Journal recently reported no ground has been broken on new coal-fired plants in the United States in more than a year. Doesn't sound like it's very significant, but that is very significant when you relate it back to the demands for power that are headed towards our country when this economy recovers. And I always try to stop and get people to think about some of the things that you hear and try to relate them to the pragmatic reality of what this country is all about. There's an awful lot of talk about conservation and driving the use of electricity down in the country and creating the need for no more electricity. And to me, it's so counterintuitive to the progress and the development of the country. We want to make things. We want to grow businesses. We want to expand lifestyles and develop new products, both here and internationally. And the very idea to think that we can stall the growth of the use of electricity, I think doesn't make much common sense. On the other hand, using it efficiently and effectively is a real key, just as we must use water effectively and efficiently, because in some cases there are limited resources. The uncertainty, the legal, the regulatory, the financial, uncertainty in many realms, not just coal, nuclear, wind, killing the birds. I don't like the optics of a 60-foot blade on my mountaintop, not in my backyard. Carbon sequestration underground, not under my backyard. We can go on and on and on, but what does it bring to our sector when I talk about turmoil and transition? It creates a real situation where companies are hesitant to try to commit to very, very, very large economic decisions. We always say in our business, never bet the company on a perceived regulatory outcome. You can get some ugly surprises. Most baseload plants that run 24/7 full load, the backbone of really what the generation technique is in the US, were built in the 60s, the 70s, and the 80s. So they are aging plants, and we infuse much capital every year to keep these plants running reliably to ensure that the power is supplied to the grid. Many of the transmission and distribution lines that deliver the electricity to customers are even older, and I'll give you an example. We replaced 3 months ago a stretch of 7 miles of 69,000 volt transmission path that was 90 years old. And so you can imagine what we paid to put the pole in 2 months ago was a lot more than we paid 90 years ago, right? And the wire and the cable and the transformers and the substations. It's a huge infrastructure business delivering electricity, just as water and sewer and highways. And we all know what's happening to the infrastructure of the United States. The infrastructure is failing. And we're in a patchwork mode of cobble it together and keep it running. Fortunately, the electric grid is not in that state of disrepair. But as you read, you know that there are communities going bankrupt having to deal with their sewer systems or their water systems. Many of the power lines are essential elements of the infrastructure to move the power where it's generated to where it's used. And without some real serious action, I believe our unquenchable appetite for electricity could really outpace the ability to supply and deliver it before your children are here enrolling at the University of Delaware. I really believe that. There are critical infrastructure decisions playing out against a backdrop of transforming change in our industry, in the electric power industry. Since the days of Edison, there's been only one other period of change that rivals the last 2 decades. The Great Depression, when the 3 largest electricity holding companies controlled half of the country's generating capacity. 3 companies controlled half of the United States generating capacity. And in 1935, Franklin Roosevelt signed a legislation to really break up the holding companies. And in 1938, it was upheld and the Public Utility Holding Company Act was passed, and it began to break up these behemoth companies and turn them into separate investor-owned utilities across the United States, much like mine that was formed around 1920-30 or so out of other companies called Pennsylvania Power and Light was the name given then. World War II really slowed the divestiture of these larger companies, and we needed, obviously, a lot of electricity for the war effort. So after the war, companies began spinning off their operating utilities as, again, independent, investor-owned. Sell stock in the public market, they're investor-owned. And for the next 50 years, that's why I use the word stodgy, boring, old. For the next 50 years, little changed in our sector. Little changed. There was significant growth. Power plants were built, power was supplied, investment was made, and the newly independent utilities really expanded their distribution grids and transmission grids and their generation and capacity, first with coal, and then we went into the 70s with nuclear. And I guess the precursors, as I call them, of the second major restructuring of the electric power industry began in the 70s. We had the Clean Air Act, the oil embargo, and I know this predates many of you, but they're very real in my mind. 3 Mile Island nuclear power plant and runaway inflation. I can remember in the 80s receiving a mortgage for a home at 15 or 16% and thought I had really snookered the banks. Greater uncertainty, regulatory delays, higher costs for generation, ultimately significant electricity rate increases. Of your spendable income, I would submit to you that electricity is still quite a bargain today in comparison to cell phone bills, cable bills, and the like. It's a very important part of the life, but a relatively inexpensive part of spendable income. By the 1990s, rates had doubled in New York compared to West Virginia. California were double the rates in the state of Washington. And you can go on and on with stories about this across the United States. As these rates began to grow, customer dissatisfaction began, and businesses complained that their businesses were being harmed. And so we began a journey to open this sector to competition. You remember telecommunications was deregulated, banking was deregulated, airlines were deregulated. We can all judge good or bad outcome. A number of states, particularly those in high electricity rates, moved to introduce free market principles to the electric power industry, and the transition has not been smooth. Flaws in the market design of California led to power shortages, rolling brownouts in 2001, and ultimately the bankruptcy of one of the nation's largest utilities, Pacific Gas and Electric. The problem there, when they deregulated and said, you, the utility, must go out and buy your power to serve your California customers at a competitive rate, but we're going to cap the rate that you can charge your customer, but you have to pay whatever you have to pay on the open market to get the electricity. Well, thus came the great saying, you cannot sell below cost and make it up on volume. And so within a period of 3 months, that utility filed for bankruptcy. Ultimately, long story short, bankruptcy court judge pulled all the parties together, said, how are you going to keep the lights on in California? The governor and the utility commission said, we're not. They're going to have to buy the power. They can't buy the power. They're bankrupt. And so in the end, logic took over, and they had to reimburse the utility for the cost of power it took to serve the customer, and ultimately resulted in Gray Davis, the governor of California, losing his job. Today, 14 states have competitive electricity markets, and Pennsylvania is one of them. Delaware, of course, is one of them as well. 8 other states that initially embraced competition have since suspended their electric choice programs. So I think if you really want to think about what is this business today, it's really in 3 parts: generation, power plants, transmission, large 169, 230 kV, 500 kV, and soon to be 750 kV lines transmitting power over long distances, and distribution, the local wires you see in the area. I would say to you that states that have restructured the electric power industry, the way it was basically done is they said, look, the distribution cables and wires and meters that deliver power to your dorms and to your homes, to your parents' homes, that's a heavy capital-intensive infrastructure business. It's regulated by each state that it resides in. And it's regulated on a return on equity basis, such that the investment that the company makes in that business to maintain reliability, the Public Utility Commission looks at it, adjudicates what is a fair return on equity, so that that company can go out and attract investors and attract the capital needed to infuse back in this aging infrastructure business. That's called regulation. Still, every wires business, every delivery business across the U.S. is regulated today. What has changed? They said, now, instead of allowing the generation plants to be under a similar system, state by state, they made the choice, we're going to separate the plants. You're going to go out there and run those plants. You're going to sell your power that you generate into a wholesale market, and it's up to you to make a profit. And if you don't make a profit, your plant shuts down and goes out of business. And if you do, you survive. So the strong survive, the inefficient and unreliable plants don't survive. Thus, competition ultimately brings the most efficient use of capital and the most competitive prices for energy. Now you say, well, who takes that energy? Well, in a deregulated state like Pennsylvania or like Delaware, Delmarva Power, who delivers your electricity, the electricity they have to get, the energy they have to get to serve you, they go out and buy it on the wholesale market. And there are many, many, many competitors that bid to that company and try to beat each other to supply the lowest price. And therein lies the competition, and therein lies the efficiency. So I think I'd say that the interesting thing is no longer are power plant owners or builders assured of recovering their costs at a profit. No more are those plants and the ratepayers captive to the costs, to the efficiencies of those plants. The ratepayers have nothing to do with those plants. The money that goes into them comes from the shareholders of those companies, not the ratepayers. The ratepayers only pay for distribution of the energy to their homes. What has happened? Unprecedented improvements in levels of performance of the power generation equipment across the U.S. The Power Generation Association really has noted that capacity factors for plants have increased from about 70% under regulation to 90% today. That is a huge increase in efficiency, huge increase, and of course, prior to that, those plants running at 70% efficiency, all of that inefficiency was passed on routinely to the ratepayer through a rate case request. Competitive generation markets have provided a platform for renewable energy development. And I think it's clear that competitive energy markets managed by independent system operators in our area, the Pennsylvania, Jersey, Maryland interconnection, provide really the best environment for wind energy development. Because as you know, wind is something that the wind doesn't blow all the time. You can't have, as they had in Texas a number of months ago, a huge wind component to supplying power, and all of a sudden one day, one particular day, the wind stopped. And all of a sudden, massive shortages on the grid, a near major blackout in Texas. 74% of the wind capacity in the United States is located in competitive markets, even though only 44% of the country's wind energy potential exists in those areas. So it's a bit of an anomaly. There were no renewables in Pennsylvania before electricity restructuring or deregulation. And today we have more than 300 megawatts of renewable energy, with more on the way. Our company has been active in developing solar and landfill biogas throughout Pennsylvania. We're developing now our first wind energy project in Lancaster County. We've purchased the entire output of several wind farms in Pennsylvania. When we purchase the entire output, that gives them the ability to finance the plant, and then we sell that into the wholesale market. There's a new issue you're going to hear about, and it's going to bring about the need for technologies, particularly in the electrical field, and that is demand response. We're headed towards a world where ultimately the consumer will be able to identify and know where their energy use is going, what the real-time cost of it is, and the devices will be placed in the home and in the hands of the utilities and in the hands of third parties that can control that energy use. Control it to ensure that we can control the peak loads, that we can use energy at the most efficient time, and that the consumer can benefit from a lower cost by using energy more efficiently. And so in that area, you begin to hear discussions of smart grids and smart grid technology. And I think if you ask 6 different people their concept of smart grid, you're going to get probably 12 different answers. It's as broad as the entire spectrum of energy, the energy business. I think what's important to realize here is that this is going to be a growing area where a great deal of high-tech products are moving very quickly by companies like Google and others, where 7 years ago, we installed what we called smart meters on people's homes, where we can, from our offices, ping that meter and determine whether they're on or off. We can transfer information with future software modifications to understand what are they using when and how much. We can give them real-time cost data that would apply to time of use rates. So all of this is geared to a technology that can give people more efficient use and control of their electricity. Unfortunately, technology moves fast, and it's not out of the realm of possibility, I believe, in 4 to 5 years that the smart meters will be outdated, and that same capability will be able to be done wirelessly with the home, absent the need for a meter at all, as far as being able to control functions within the house. And factories, and there is the issue of demand response. People in the future will be paid for their okay to curtail their energy use at any given point in time or over a long period of time. That way, peaks and valleys in usage and demand can be managed, because power plants are built not to supply basically the base load. Power plants have to be built to have the capacity to meet the highest peaks in summer and the highest peaks in winter. And so you can see, by designing plants that way, there is a bit of a wastage, that you have a very, very, very large reserve margin required to meet the hottest day without creating a brownout or a blackout. If the peaks are able to be controlled, we can levelize the use more and thus minimize the need for new, larger baseload plants that are so expensive to build. In 2008, demand response customers in PJM, demand response customers received more than $25 million in payments for curtailing their electricity use. So if you're running your plant or your factory and you realize, look, prices of my product are at X and I can get X plus 3 by curtailing power over a certain period, all of a sudden you're in the power business, not the widget business. That works well for everyone. We've talked about choices, and I think the best way I can demonstrate choice is in Pennsylvania. This was the first full year of deregulated customer choice. We have regulated delivery businesses in Pennsylvania, in Southwest England, and Wales over in the UK, where we just solely deliver electricity over our wires. In Pennsylvania, we have 1.3 million customers, and this year, for the first time, individual residential customers had the ability to go to the wholesale market through various suppliers that advertise to them and look at the prices for their energy that they were going to pay and choose to shop or to stay with PPL. If a customer chooses not to shop, and this is the heart of what deregulation is all about. So I'm hoping some of you can walk out of here and be able to explain this, because I've been trying to explain it to customers in Pennsylvania for 10 years to no avail. But when a customer has the right to shop, if they choose not to shop, we have an obligation to be there for energy, for power to their homes. And so we're called a default supplier. If they choose not to shop, we've got to supply them. Of our 1.3 million customers this year, 400,000 of our customers shopped and chose another supplier at a better price. So when you think about customers, let's talk about, okay, of our whole Pennsylvania service area, how much of the real energy load shopped? Almost 50% of the energy that we would normally sell in our entire region shopped and went to other suppliers. That's what competition is all about. They sign one-year deals, and each year people come back and shop. I think that I would say that competitive markets provide benefits now and over the long term. But I think that we are in a world of political uncertainty. And we have made somewhat of a mess of the United States by deregulating 14 or 15 states and then having the rest of the states staying in a vertically integrated, regulated mode where the plants and the wires are all regulated on rate of return of equity basis. And so we have not created nationwide wholesale markets, which has hurt the efficiency aspect of the whole concept. There will be no more regulation, deregulation as I see it in the United States. I just don't think it's going to happen. It's too much of a political football. Will deregulated states remain deregulated? Some have not. The future will tell. But I can say we're in a state now where there are 3 different types of utilities. Vertically integrated, regulated. All the plants, all the wires, all the delivery, it's all regulated. They go to the PUC every year, 2 years, 3 years, and say, this is what I've spent, this is what I've invested, and I think this company X deserves an 11.5% or 12 or 10.5% return on equity. And the Public Utility Commission adjudicates those expenditures. They decide whether they're prudent, whether they're necessary, whether they're fair, and they decide what that's going to do to increase the rate of the customer, and they award a new tariff that covers those growing, ever-growing costs. The second type of company is what we are, which is a hybrid. We have regulated wires and we have unregulated generation. And so we sit out there as a different, unique company. And then there are third types of companies in our sector today, purely generation, purely merchant. All they have is power plants. All they do is generate power, and all they do is sell it in the wholesale markets. So now we sit in the United States with 3 different animals. And which one is going to survive? I wish I could tell you. They run from in favor with Wall Street to out of favor. Last 3 years ago, the hybrids and the merchants were in great favor with Wall Street because prices were on an upsweep. Natural gas, which generally sets the prices of wholesale markets, was 110, or I should say power was $110 a megawatt hour. Over the last 3 years, power prices have fallen 70%. Over the last 2 years, we've left $2 billion worth of gross margin on the table, or lost it due to the power price falls. So now hybrids are out of favor, and the vertically integrated regulated utilities are in favor because, you know, it's kind of nice. You can go in and say, I spent this and I need this, and life is good. As prices come back, it'll shift again. And Wall Street is always looking to who can deliver the most bang for the buck. We have a big challenge ahead of us. The Brattle Group, many of you may have heard of the Brattle Group, estimates over the next 20 years we're going to need $2 trillion invested in the electricity infrastructure in the country. That number begins to concern people about, can it be raised? Will the capital be there? That includes more than 200,000 megawatts of new generation, which really equates to hundreds of new plants. Our twin nuclear unit, just to put it in perspective, is 2,300 megawatts, and it's a very large plant. So 200,000 megawatts is a big increase. The wire side of the business are going to need these expenditures because the aging, as I mentioned earlier, is very, very difficult, very, very rapidly degrading and increased failure rates. So we continue to spend immensely on coal-fired plants to keep them running because they're half the country's generation. We find that the increasing federal and state regulations are very detrimental to ongoing coal, which is our largest I would say indigenous supply. One might say, well, gas is pretty good too, Jim. It is. But one thing about gas, it has wild, rapid commodity fluctuation in price. In 1990, gas was $4 a million BTU. 2008, it was $12 a million BTU. And today, it's $4 a million BTU. So these commodity swings can really play havoc with your bills. I think a lot of people ask me about the nuclear industry and as well climate change. I always tell people climate change legislation is something that should be federally legislated versus states, so that we don't have 50 regulations, each one trying to top the other. The uncertainty is outlandish. And I've always felt, at least in the industry, we've tried to tell the political entities in Washington, if we're going to go ahead with this, understand the ratepayers are going to pay. It's going to be extremely costly, and understand what you're doing to the economy if you pass this legislation, particularly when we have no real commitments from some of the developing countries that they're going to attack this as aggressively as we might propose we would. And if that doesn't happen, all that we can do in CO2 reduction will be dwarfed by the large increase in CO2 across the world through developing countries. So it is a great political issue to deal with, and a tough one. Nuclear. Well, we have, I think, managed to stall a nuclear build out in this country that began in the late 60s, early 70s due to 3 Mile Island. And, you know, I don't generally, rant and rave about how good or how bad it is, but it is carbon free. The safety levels and efficiency levels of the nuclear industry are unparalleled over the last 25 years. The issue there is the cost of the plants have become so large that the financial risk is so great that the only way they can be built is on the basis of a pay-as-you-go by the ratepayer. We currently are working on a combined construction and operating license for a third unit, with no decision yet to build, but to preserve the option for the future. The plant we're looking at, fully financed, will be $16 billion. The market capitalization of our company is 10.5. So it's really a bet the company proposition. And so you can't go forward with something like this without joint venture partners, and you can't go forward with something like this without federal loan guarantees, which mean having those federal loan guarantees doesn't mean that if you feel like you don't want to pay off your debt, you can. No, that's not what it's about. But having the federal loan guarantee allows you to finance a plant like that with very high levels of debt and low levels of equity. And so that allows the smaller market cap companies in this country to be able to even attempt one. My comment to you is you will see new nuclear plants over the next 10 years. You will see them predominantly in the South, and they will be built by fully vertically integrated regulated utilities where they will begin to recover return on and return of the investment on an ongoing basis through the whole construction period. Whereas if I were to build one, I would start spending day one, and 10 years later I'd receive my first nickel of income, having spent $16 billion over 10 years. It's a very risky proposition. So therein lies the challenge of nuclear. I guess I would say to you that our electricity business has become, from my time in the 70s at Delmarva to today in 2010 at PPL, I have never seen such complexity come into a business. I could have never dreamed that in my daily world, I'm talking to and listening to, I should say, usually listening to, PhD mathematicians who manage our portfolio risks of marketing and trading. We have a trading floor where we trade real time on power as much as 4 years out. We trade it hour to hour or we trade it 4 years out. And so those risks can be huge. We deal in all sorts of financial instruments, derivatives, caps, collars, puts, calls, very similar to what is done on Wall Street, but I always say we do it a lot more controlled and sensible and less risky. Our nuclear business is very challenging from an engineering perspective. We are pushing plants and expecting more of them, but maintaining our safety margins. So our nuclear fuel designers and our nuclear engineers and our chemical engineers that work in designing the core design, we refuel a third of the refueling, or a third of the core gets refueled every 2 years in our units. So each time we redesign the core for maximum efficiency and maximum power output and ensure that we maintain regulatory margins. So nuclear and chemical and core engineers work in those fields. In the nuclear plants themselves, as we extend the lives of them, we redesign the mechanical components, the electrical components. Strangely enough, this will blow your mind, but the nuclear industry, that many of these plants were built and placed online in the late 70s, the early 70s, the mid 80s, and the late 80s, we are now just converting to digital controls. And yet in fossil plants, coal plants, we converted to digital controls many, many, many years ago. Why is that? Because of the risk of change in a nuclear plant. The Nuclear Regulatory Commission and the time it has taken to perfect and improve those designs by the engineering firms and our engineers to be able to go in and flawlessly install and never put the core at risk or the plant at risk has taken many years. So change and innovation in the nuclear industry is coming, but it comes with a great cost and a requirement of very, very, very talented people. Climate control, you tell me. It's basically putting chemical plants before or after new or existing plants to remove CO2, and with the idea that we are going to sequester it underground. Now, it used to be years ago, I said to Ken earlier, it used to be years ago, it was NIMBY. You'd come along and let's build a plant in your backyard. Not in my backyard, you're not. Now in the future, I'm afraid it's going to be, let me sequester CO2 under your neighborhood, and you're going to say, NIMBY, not under my backyard. I think it will be one of the greatest legal and technical challenges the country could ever possibly face, and I'm not sure it's doable. And so this, in my mind, is one of the things we have to step back and think about. When we pass costly legislation, we darn well better know that we're not going to be capturing CO2 and then determine we can't put it anywhere and let it go into the atmosphere. What have we done other than run a tremendous cost up? Now, I met with some of the key technology companies that are working on CO2 removal. And you take it for whatever it's worth, about 2 weeks ago. And I finally, after hearing and going through the entire amine process for removal of CO2, the comment was made, it's been very difficult and there's a lot of scale up to be done. And I said, so tell me, the whole objective is to develop a technology that I, as a coal plant operator, with climate change legislation that says, we're going to charge you, Jim, at your plant for every ton of CO2 you emit. We're going to charge you X dollars. And we're going to charge you high enough that at some point you're going to say, gee, it's more sensible for me to install the removal technology than keep paying the surcharge for emitting CO2. And that's what climate control is all about. Create a cost that's high enough that would cause you to take the next best or the better alternative of installing technology to remove it and sequester it. And I said, what's the cost, what's the carbon cost going to be? And the answer from an individual that is involved in the lead technology development and has made the most progress in removal of CO2, $70 a ton is where they're thinking. So $70 a ton, my friends and fellow students, will cause your electric bills to go where no man has gone before. They will be large. And so this is the challenge that our government is under. This is the strain and the stress of, do we do this? How do we do it? Can we accomplish anything? Because if you can't set the incentive to cause people to switch to the technology, what have we accomplished? So it's like anything else. I always say to my wife, you know, it's a great concept as long as we all understand that someone's going to pay. And that someone is us. So I would encourage, I guess, from my perspective, when you pursue your electrical engineering and your computer engineering areas, I would encourage you to think and to explore what is going on in our sector. It is not the old stodgy game that many people labeled this industry years ago. We have financial people as traders, we have engineers as traders, we have core engineers, nuclear engineers, chemical engineers on the cutting edge of technology. We have mechanical engineers that work night and day on developing the tooling and the techniques where we go underwater in the reactor core at a refueling outage and do underwater machining 30 feet down where the radiation levels are so high no one can get near, and they're all remotely controlled. And the machining is done by looking at the TV screen, but the tooling all has to be developed. How do we cut? How do we weld? How do we examine for thickness, and on and on and on, that technology. We need, if the renewable business in our sector is going to grow, we need people that can vastly improve the cost of wind, vastly improve the cost of solar. If we cannot improve the efficiencies, then all of this talk about the green economy and the green jobs, rest assured it will stop, because you cannot continue to heap costly technologies on the ratepayer because they, and say it's for the good, the greater good, because they will not be able to pay their electric bills. And for any of you that don't know, when people can't pay their electric bills, who pays? You pay. It's socialized. So I think that when we talk about removing carbon, we look at what we call a rainbow diagram. And the Electric Power Research Institute, which we work with as an industry very closely, some of the most skilled engineers I've ever seen out in Palo Alto, California, they really lay out for Washington and all to see that there is no one silver bullet, that we need, when 50% of the power is generated by coal, we need, if we're going to solve CO2, we need CO2 removal technologies. And we need clean coal plants that can be built, and CO2 is removed on the front end, basically by adding a chemical plant. But we need to do something with CO2. Those challenges are immense. Immense challenges. We need nuclear. And so with nuclear, we have to find the financial challenges and understand how we're going to do that. And part of that, I believe, coming is a great consolidation in our sector. Companies our size are going to have to merge with other companies and be bigger to get bigger balance sheets and be able to deal with these large financial problems. Renewables. Renewables is not a silver bullet. Renewables can only produce, right now, renewables, as I said, are 4% of the generation, 2% of it roughly being wind. Maybe, if we are lucky, and some of you out here develop huge efficiency improvements in the renewable world, we can get to 20%, 15% after 20 or 25 years of renewable. And I think natural gas is always going to be a wild card because of the wild swing in commodities. And if I want to build a 600 megawatt natural gas combined cycle plant today, it's going to cost me at least $1,200 to $1,500 a kilowatt. So I mean, I'm talking $1 billion plus. If I'm going to build a coal plant, it's going to cost me $3 to $5 billion. Now, if I'm going to build a nuclear plant, it's going to cost me $14 to $16 billion. So these are huge numbers. And in our sector, we are not structured for them. A parallel I would draw is large companies like Exxon or Mobil or oil companies that their balance sheets are very strong, and they rarely build a refinery that they are not covered with many joint venture parties, and their investment is a mere small part of their market capitalization. So what I'm saying is we have too many, 250 or so utilities in the United States. We need to move back in the direction from where we came. I'm not saying move to 3, but we certainly don't need 250 because we can't deal with the costs that are going to be in front of us as we go forward. With that, I think that I've used up a considerable amount of time, and geez, no one has thrown anything, and most of you are awake. So I can only tell you that when I graduated here, little did I know where I would end up or what I'd be doing, and I had no grand plan. I took the best job offer that I thought I would be interested in and would enjoy and like and could add value. And I moved along never really with having a plan that I want this or I want that. I sort of am a pretty simplistic guy. I'll do the best I can in this job and enjoy it as much as I can and treat people right, and those opportunities will open up. At least they did for me, and I believe they will for you. I'd be remiss if I didn't say one thing that I've learned. Probably the most important thing I've learned in all my years, and it's not something you get out of a book. And that is that a big part of your success, and however you want to define success, is how you hone your ability to work with others and to work with all types of people. To me, that is the most important thing that you can never, ever forget. Now, I'm a guy that deals in facts and numbers, and I can tell you this. One of the hardest things that I ever had to do 30 years ago, and the same most difficult thing today, is to let somebody go. And I can not count. I can count, let's say, on these two hands, the people that have failed due to lack of technical knowledge. That few in that many years in my world. I can't begin to count, wouldn't even venture a guess at how many people have been removed because they don't have the ability to work with other people. Just the way it is. And I don't think it's anything new. I think it's as old as time, but it's something to think about. You'll receive wonderful education. You'll be, the tops of your classes and brilliant and innovative. Those things are critically important because they're critical to getting jobs. Rest assured, when we look at new engineers, I feel like I've struck a new barrier when I've talked our way into saying to people, listen, I'll take a 3.5 or a 3.4 graduate, but I want to know how are they going to be working with people. But that was a battle because we're at 3.8 or above, or 3.7 or above. So I say that to you, wherever you fall, your personality and your ability to relate with people are going to be a big part, perhaps not of landing that first job, but I can guarantee you the level of maturity and the ability to work with people and the ability to deal with conflict and conflict resolution is going to be one of the keys that take you where you want to go. There's not too many jobs out there where somebody's going to lock you in a room and you don't have to interface with anyone. So that's a piece of free information that I've learned over the years. I hope that you see that there is a broad area of engineering, and I hope that when we come down here and hang our shingle up and try to attract, within the next 7 years at PPL, we will lose 50% of our workforce through retirement. Next 7 years, we will lose 50% of our workforce through retirement. That's this whole baby boomer demographic issue that the whole country is facing, and that's going to be good for you all. You're going to be in demand, rest assured. There were about 15 years where we literally hired no one, and so there's this huge gap. The average age of our company is 50, and so we have a young cadre, we have a gap, and then we have a more mature group of employees, as they tell me to say. Not that there's anything wrong with old, I'm old. So your future, to me, as I see it, is tremendously bright, because you're seizing right on this moment of demographics. So I encourage you to give us a shot if you're interested in being part of nuclear or being part of planning or trading or marketing or our quant work and our risk analysis. And I think what we try to do is develop people and push them. When we find people that can tackle issues, we push them. We push them well out of their comfort zone. And that's what really makes a company be able to survive in the competitive world that we're in. With that, I would close and say if there are any questions, I'm open to them. If you have anything or comments, or you're not going to hurt my feelings, you're not going to make me cry, or anything you want to know about our sector, it's your nickel. Yes?
Hey, Jim, when you look at the consumer costs of energy in most other places around the world, Europe, Asia, you find that people are paying for gasoline, 2 to 3 times what we pay.
Sure, $8 a gallon in the UK.
For electricity, they pay double or triple what we pay. The models elsewhere, put taxes on energy to make people pay more for it so that they'll use less of it. Those pricing structures allow renewables to pretty much be, online straightforward over there.
Right.
Do you think we're just whistling Dixie with trying to maintain our energy pricing it to the consumer as low as we are?
I guess my answer is no. I believe that energy is so important to the growth of the country that I believe our mission in this country should be to form a national energy policy, not 50 national energy policies through 50 states. And that is our dilemma. As long as I've been around, we have talked about administration after administration, the energy bill. We've got an energy bill. We're in the situation we are now, unfortunately, because we've never really been able to form a cohesive energy bill. We've got so many directions from so many states and so many views on the matter. I think that creating higher costs I guess by artificially creating higher costs to cause people to conserve is the wrong way to go. I would much more be supportive of a full wholesale market in the United States where the real cost of power would be reflected to all consumers. Either that or go back to an entirely vertically integrated, regulated electric utility where the ratepayer pays the freight as they go to put on the generation, to do the delivery work. You all know how this all came about. It came about by people saying, you know, those PPL or those Delmarva trucks, I just saw 4 guys sitting at the coffee shop and they were all in there sipping coffee, and that's regulation. They get their money, they don't have to work, they're all lazy. We need to change something. We need to deregulate. Well, now we deregulate and they say those bums are ripping us off. They're making a profit. Let's re-regulate. I mean, this is what's going on here. So I won't use the exact vernacular, but in the Navy we used to have a saying, a complaining sailor is a happy sailor. So you can't have it both ways. You can't complain about the regulated Delmarvas or PPLs and they're not running their plants well and it's costing us more money and the PUC's giving them good rate increases, and then deregulate and say, wait a minute, these guys are making a profit. They shouldn't be making a profit, even though the ratepayer's not taking the risk. You can't have it both ways. Either way, I think my point is, the dilemma is we have segmented the type of companies, and that's non-optimal. Let's be one thing or the other, and then drive it to the most efficient outcome and the lowest possible price for the consumer. Because in the end, we want people to use, we want factories to make, we want products to come out that use electricity. And we'll work, be driven or drive ourselves to use it more efficiently. Yeah.
It's sort of an extension of that question. At the present electricity prices, it seems to me that there's so much room for improvement with insulation and even light bulbs. Not everyone has switched to compact fluorescent light bulbs. So I'm wondering why you think that some market hasn't been created to take advantage of these opportunities. For example, a company might go out and insulate a home and put up the capital up front to do that and then get the returns later. And I know in Delaware they're trying to do that with a sustainable energy utility.
Yes.
It's just not sure why it hasn't been done yet. It seems sort of common sense.
I think that the basic, at least a good part of the answer, is that until you or I or someone else feels a cost of energy that would make me say, whoa, turn that light out, or shut that door, or geez, if I insulate, or if I put on a coating on my windows, or if I do whatever you're talking about for efficiency improvement, until people realize that there is a relatively quick payback on that, they're not worried about it. And so I am by no means standing up here telling you electric bills are cheap or free. No, of course they're not. But as I said earlier, the cost of electricity is still at a level. Still at a level. And I would guess here in this area that the average electric bill is 750, 800 kilowatt hours a month. Probably people pay $100. $100 a month, somewhere around there, 110, 120, 90, whatever. Okay, $100 a month. I mean, you know, if you smoke cigarettes, it's more than that. If you have 4 kids and 6 cell phones, it's, I don't know what it is because I don't, but if you have all the cable and WWF and all the football games on, I mean, that cable bill is like $150 at a pop. So I think it's, you can't create, businesses can't survive when there's not enough customers to take the product of insulating or efficiency improvements.
But it's still profitable. Like you're saying there's not enough customers because they're not thinking about it because the price isn't high. Is that what?
That's what I'm saying. That if the price is high enough, unfortunately, someone's going to say, wait a minute, I'm going to contract the guy to come re-insulate my home or evaluate it for energy savings or put new storm windows in or this or that. And I wish there was a different answer, but that's what we have seen in our business, that people still, I mean, so many people, you ask one spouse, and if the other does the bills, the one spouse never even looks at the electric bill. That's just a fact. So, but I do not believe in falsely inflating the costs to cause these things to happen. I say, let the true cost of power be reflected to the consumer, and the rest will happen. The rest will happen. We're under a program in Pennsylvania where we are forced to cause conservation. Now, how do we go out and force you to conserve? You know, I can't charge you and say, if you use more power, I'm going to increase your charge. Can't do that. We have a flat tariff rate. So we go out and we now commission contractors to try to coerce, convince, cajole customers to say, please use less and your bill will be less. It's not the most effective way to go at this, right? Most customers might say, no thanks. You know, I like my TV, I like my flat screen, and, you know, yes.
One area of competition you haven't addressed is in people. How are you going to attract new employees against the Googles and the Apples? And on the supply side, there aren't that many universities who offer power options.
That's right.
Engineering department, and even fewer community colleges training in.
Yeah. It's a very good question, and it's a very big problem, as you realize. We are doing an awful lot of work with community colleges in our region. Particularly, you know, you take a reactor operator, which is generally most all of our licensed operators are now 2-year or 4-year degrees. I'm talking about senior reactor operators, not just the general bench board operator, but we're working with local colleges, junior colleges, to get people into programs where we can jump them into our training program. It takes us literally a year and a half of classroom and then 2 years of on the job before anybody can touch the panel. So we have a tremendous training, internal training burden on us. We are as well talk about engineers and all types of engineers. We try to focus on schools for our delivery business, engineers that understand load flow analysis and transmission and distribution loading. Of course, everything now, unlike years ago, everything now is done by the computer, but we still need those engineers that understand reliability of the lines and how much can we load them, overload them, etc., and all the automated load flow studies, it still takes the human interface. The designers to design the new substations, to design the larger transmission lines. So we are looking at schools where those type programs exist, and where they don't, we're looking for good, solid engineers that are willing to come in and go through our training to learn. So it's even more difficult on the craft side. How many in here today want to be a boilermaker? How about a millwright? Well, you know, no one wants those crafts anymore, but when you're out there in the plant and you require those kinds of skills, a lineman, and you like to climb a pole and deal with 138,000 volts and be doing live changeouts 100 feet in the air. Not a lot of people want to do that anymore, young people, but there are still plenty that we have to take, and it takes us 4 years to get a person capable and trustworthy to send them up there and deal with a live switchover. It's dangerous work. Yes? One more?
So you were talking about the consolidation in the sector. What is the time frame that you see for that, and how many companies do you think at the end they will be there?
Well, I think it's going to be a relatively slow consolidation. Years ago, there was all the predictions that it was going to be a massive consolidation, but there are always obstacles. There are obstacles with public utility commissions about mergers and taking jobs from one state to another. There are issues with a public utility commission perhaps saying, okay, you want to merge, tell me how much money you're going to save in this. And you say, well, I think through the combination we can save a collective, you know, $5 million, $10 million, $100 million a year. And it's not too long till they say, well, I want you to give 70 of it back to the ratepayers if we approve this merger. So there are economics involved. And in some cases now and nowadays, the question of synergies that would develop that 100 or so a year, it doesn't even stop at the synergies. I don't really care how much you gain by merging companies. This is what I want the check to say. And so you write this check or you don't merge. And so there have been Exelon out of Chicago and Public Service Electric and Gas out of New Jersey attempted to merge. And the request from the Jersey regulator was so phenomenal that they both had to walk away from the merger. Constellation Energy out of Baltimore and Florida Power and Light tried to merge. And by the time the Maryland legislature got through with them, that merger fell apart. So it is difficult for those reasons, but I think people are trying to find the areas where it will work and in the jurisdictions that it will work. That's why I say slow but steady.
Jim, thank you very much. It's a terrific lecture, very inspiring.
Thank you. Thank you. Thank you. Good luck to all of you, and I wish you all the best and a great future. I am convinced you're going to have one as soon as you get the old guys like me out of the way.
As usual, we have a reception.